Please do it.
Okay, welcome to my presentation about WİMAX, and today we are going to present WİMAX, which is the newest tool worldwide interoperability for microwave access. And today, as a contents you see introduction to WİMAX, and then we are going to know how can we use WİMAX and how it's working, and some standard for IEEE standards, then architecture, specifications, and so on until future WİMAX. First of all, before going through WİMAX in details, we have to remember the telecommunication model, which contains a receiver and channel, and a message delivered, and a tower or a source. Or transmitter, and in this case we are talking about WİMAX, so we are talking about a source for WİMAX as a tower, and a receiver for WİMAX, which is different. We'll go in details, but you have to remember. And the channels for this, which microwave, as I said before, it's a worldwide interoperability for microwave access. So the channel used is microwaves, not cables, and not fibers, not
radio communication.
Yeah, anything else. So in this case, WİMAX, as I told you, the microwave access, and this has a standard for IEEE, which is Institute of Electric and Electronic Engineering, which made a standard for this for 802.16. And this standard had to be competitive and interoperable for broadband access. And then the WİMAX tower, as I told you before, transmitter has a range, a wider range than Wi-Fi or broadband access. Has a range for 50 kilometers as a radius from the center to the access point or to the receiver. And this makes an area for 8,000 kilometers square, something like this, and it's a wide area in the case for comparable with Wi-Fi or broadband. The next slide, or thinking or internet. What's the internet? How can we use internet? How can we receive the internet? First of all, start with dial-up connection, and then develop to use broadband access, which using DSL and cables, and then going to Wi-Fi access, which has a standard also from IEEE. But in this case, we are going in levels. The first level has some weakness, so we have to do some developments and improvements to this method. That's why we have to use a broadband access, and then this broadband access also have weakness. That's why we go to another improvement, which Wi-Fi. The broadband access has costs out of money, costs material. So that's why we have to use microwave or waves to transmit data from point to another through Wi-Fi. But we can't stop at this point. We have another technology with a wider area, as I told you, 8,000 kilometers square, and with radius 50 kilometers. But for Wi-Fi, which we will listen to it later, it will be narrower than this area. And also the speed for connection and the data transfer. Also, it more than the Wi-Fi access. So the next one consists, as I told you, the first. Yeah, as I told you in the first slide here, we have the source, which is a tower here, and the receiver, which may be in your laptops or in your mobile phone as a built-in receiver, or maybe a big receiver for another technologies to connect the data to you, maybe B2 MEB, which point to multi-point or mesh, and we go in details with this method. And this source, as I told you, is a wider coverage and higher speed for transferring data. So going back to our slide here, yes. This is a shape for figure showing the tower, how it works, and also this tower not just covering a wide area, it also provides two types of scale or two types of spectrum frequency. First one is the lower, which is from 2 to until 6. From 2 until 11 gigahertz, and this is a low frequency. And the other type, which is a higher frequency, from 10 to 66 gigahertz. And we will go in details with these two types, what's the difference between them and when can we use them. So this is a figure how it works. So also from the beginning, as the internet come from internet backbone here, as you saw, and this is provide internet to internet service provider ISP network, with we call it a big server, which provide internet to everybody. And through this we have a connection between server and the towers. With cables, with waves, it doesn't matter. It's important here to this connection. And also this is a connection between towers, then the connection come to use inside homes, inside the public gardens or parks, or in mobile. You can use this for mobile. And here we find something interesting with line of sight backhaul and non-line of sight. And we will go to explain the differences between them. The first one is a mode of operation, line of sight. As you see in this picture, it's direct. It's the same, literally, meaning I see you directly without any thing obstacles like chairs, like anything can obstacle this. And in this type, we find that the transmitting is using a high frequency. Why high frequency? Using high frequency is more much better than using low frequency. It can provide more data and transferring with a higher speed. And in this scale, going with okay, we can pass this and go to non-line of sight, which has, as I told you before, has an obstacle between you and between the tower and the receiver. And this obstacle can absorb your data. We are talking about a microwave. A microwave meaning wavelengths can be absorbed, distorted, or anything else. So in this case, we are using a lower range, which is from 2 to 11 gigahertz, and this range have longer wavelengths. With this longer wavelengths can absorb it easily. So that's why we are using a lot of reasons for this, but one of them, as I told you. And in this case, the area coverage is not 50 kilometers, as I told you, but more or less, and maybe it's as 10 kilometers, and also it's 10 kilometers a wide area, not only 50 kilometers. Another reason to go back here for line of sight. Another reason for this range, as you remember, for transmitting data, the frequency is proportional directly with the energy. And if you have a much frequency or a higher frequency, it means a higher energy or much energy, and it can this energy is able to provide data for a longer distance. So we have enough energy. That's why it can be provided internet through 50 kilometers radius, more than the other one. Here it's not higher frequency like the other ones, lower frequency, which cannot go for 50 kilometers because the frequency here is lower, and so as a reason the energy is lower, so it can travel anymore longer. Here, as you remember, I told you before that think of internet and started with dial-up and then start going for broadband and so on. And this way is also going back to the history of connecting or telecommunication. We have a lot of things to connect. We have a small area which come to few meters with connecting Bluetooth. If I connect my phone to your phone with Bluetooth, we can go for more than 10 meters or 20 meters or more. We can go like this. So it's a narrow area. Going up to, and this also is called PAN, which is personal area network. Personal inside us, inside our work, inside our room. And the other one is called LAN, which is wider local area connection, which can connect data through two buildings, near buildings, or through one building, because it's here the maximum range for this data is transmitting data through 300 or 400 meters using the cables like this, and going more for wireless man with metropolitan access, metropolitan internet. It's more wider as area, and using WIMAX in this coverage, and go wider and wider. And also we don't know that in the future we'll find something can provide data for all the earth. I don't know, we can find it later. So as I told you, the frequency used in towers, provided from towers, can provide data for long distance or lower, shorter distance, as it's or a higher frequency or a lower frequency. So that at the maximum 30 miles to provide, which is 50 kilometers, and also can provide internet speed for 70 megabits per second. Which is two frequencies. Frequency band, I told you this before, we can pass this. Going back to the history of WIMAX, we can find 5 specific WIMAX developments come through. The first one, which is WIMAX IEEE, which comes from Institute of Electric and Electronic Engineering 802.16a, which found in the end of 2001. And this come to provide internet for 2 till 11 gigahertz, which is lower frequency, which is also can provide internet not wider area, but just a few thousand of kilometers. Another thing come here, which is 802.16b. Come okay, I'm going to pass. Has increased spectrum, another spectrum of frequency from 5 to 6 gigahertz. Another one which is used, as I told you, from 10 to 66 gigahertz, and have improvements. Something it's notes here that the WIMAX technology. This technology not providing internet just for stationary state like us. We're using this without moving, using your device without moving, but also provide this data while moving. You can use your car, because the wide area, you can use your car while using your laptop connection without losing your connection. Also for telephone, not just laptops. One remarkable here, for mobile phones, 3G or 4G, fourth generation for mobile phone will intend to be used WIMAX as internet provider. I told before, providing internet through 2 ways, common ways in WIMAX. The first one, P2MP with point-to multi-point connection, which is shown here in this picture. Just one point provide to a lot of points. So we are here getting our data from using this connection from outside, if you are connecting to our Wi-Fi tower, or in public garden. We in public garden, like our public park, like the same situation. We take the connection not from router, but just directly from the tower. The other way to connect is having a mesh architecture, which is providing the internet to a router or receiver, and this is taking its role to provide internet for other users, which is shown here as you see. Just providing internet for one, and this is provided for a center, and this center provides for a lot of devices here. That's the way which is called mesh architecture for providing internet in WIMAX. Here are some features. Nothing important. Frequency band, I told you, not just from 2 to 11 gigahertz, also from 10 to 66 gigahertz. As you remember, line of sight and non-line of sight. And also a range of 50 kilometers using a higher frequency, not all spectrum of frequencies. And the speed is 70 megabits per second. And the coverage, we talked about the coverage before, which is providing about 8,000 kilometers square. So the benefits for WİMAX. WİMAX can is faster, as I told you before, faster than Wi-Fi. It's coming to add improvement to of Wi-Fi and improvement for broadband access, and using wireless, so it's costless, not expensive using wire and materials, and also easier to extend subterranean and rural areas. Go through areas and you can connect not near to tower, you can connect far away. And broadband coverage. So uses for WİMAX, as you told you before, here is like a public garden or public park, which is provided point to multi-point connection, and here for normal users for working office. Provided internet, and all this internet come from here from ISP with internet service provider, and come from internet backbone. Here more applications like as you see here, wide area coverage, wireless, mobility, vibrator network backbone, internet backbone. Here from here internet come and then to the tower. From towers can using internet for mobile, using wireless moving, and also stationary levels, as you see. WİMAX not has just advantages, also has disadvantages with using wide area coverage. It means that at the distance of 50 kilometers, as I said, there will be a connection, but with less data transfer than in near to the tower or a few kilometers. And that's all. Thank you. If you need a lot of information or more information, you can visit these references. And thank you.
Okay, thank you very much. Please reach button.